So today's objectives are we are going to review measurement, freezing and melting point, solid liquids and gases, and mixtures and solutions. Someone raise your hand and tell me what I have to have in order to have a solution. Mario.
It needs to have two objects.
Okay. Who wants to add to that for a solution? I need 2 or more objects. What else has to be special about it? Ramson, solution. What's special about a solution?
You can't separate them.
Thank you. That works. And what about the molecules? How are they distributed? Michael? They're evenly distributed. So does that mean that things are going to taste different from one part to the next, or the whole substance will taste the same? All taste the same. Good. And in order for molecules to be evenly distributed, what has to happen? Yesterday we talked about this vocabulary word. Something has to, Ian? Dissolve. Good. When something dissolves, does it disappear, or does it just get so small we can't see it? Good, because by the flavor and things like that, it's actually still there, right?
Yes.
Good. Okay, so let's get started. Okay, so since we're going to be studying liquids and solids today and the freezing point, I need someone to come up and draw for me what a liquid would look like. Daisy. Thank you. And in a liquid, is there definite shape or no definite shape?
No definite shape.
No definite shape. Definite volume or no definite volume?
Definite volume.
Good. Who else can come up and show me what a solid would look like? Andrew? Okay. And everyone, in a solid, the molecules are what?
Tightly packed.
Tightly packed. Good. Very good. Now then, for this to happen, the arrow has to be a certain process when the liquid turns into a solid. Someone come up and write down what that process is called when you go from a liquid to a solid. Ian? Just write it on the arrow. He is writing freezing. Does everyone agree?
Yes.
Yes. Okay, so now then, one more bit of information before we get started on our actual experiment. At what temperature does freezing occur? Who thinks they can come up and write that? Michael? At what temperature is our freezing point? And he wrote, what did you write?
0 degrees Celsius.
Does everyone agree?
Yes.
Yes. Good. Okay, so I noticed before we started making, trying to get to our freezing point, that you had put sugar into the bag, but then I couldn't see the sugar anymore. So what happened to the sugar?
It dissolved.
Dissolved. Okay. And what temperature are you going to have to get your solution to in order for it to freeze?
0.
0. Okay. When we take it out of the ice, at what degrees is it going to start melting?
10 degrees.
No. 0 degrees too, remember? Freezing and melting are both 0 degrees. Are your hands cold? Okay, I see that you have a paper towel wrapped around your bag. What is that doing for you? Keeps heat? Yep. So what? It's an insulator, okay? So your hands won't freeze to death, right? Ramson, so if we are making this into a solid, what is the solid going to look like? Is it going to have definite shape, no definite shape? What's it going to be? Okay. Would it take the shape of its container, or would it stay in its own shape? Stay in its own shape. Good. How's that solution?
Good.
You did, okay.
Were you able to reach the freezing point?
You're not going to think you're cool.
Good. Daisy's being inventive to get to every last drop. Delicious.
I forgot to tell you about this. I got a plastic bag and I put icing in it. And then I squeezed all the air and I sealed it. I poked the hole. I had animal cookies all over the place and I started dripping and dripping inside.